Let f of x equal x plus 1 over x, and g of x equals x plus 17 over x plus 2. Then find the domain of f and g, and find f composite g, and simplify f composite g to find the best possible, and find its domain. First, start with f of x and find its domain. The domain is negative infinity to 0 and 0 to infinity because 0 cannot be in the denominator of 1 over x. Then find the domain of g of x, which is negative infinity to negative 2 and negative 2 to infinity. This is because negative 2 makes the denominator 0, and again, you cannot have 0 in the denominator. Next, find f composite g, which follows the following steps. The steps are continued here. Finally, to find the domain of f composite g, you take the denominator and set it equal to 0. This is because the denominator cannot be 0. In the end, you find that the domain is negative infinity to negative 17 to negative 2, and negative 2 to infinity. Let f of x equal 3x minus 1 over 2x plus 4 and find the inverse function. Then, let 2 raised to the 2 raised to the 2 raised to the x equal 512 and solve for x. Starting with a, first make f of x equal to y. Then, swap x for y and solve for y. The steps are shown below. Finally, replace the y that you solve for f negative 1 of x, and that is your solution. For part B, take the equation given and make 512 equal to 2 over 9 because it's the same thing. Then, as a law of exponents, when it's the same base, the exponents are equal. So it's now 2 raised to the 2 raised to the x equal to 9. Then take the log base 2 of each side. The log base 2 cancels out the base 2 on the left side, leaving you with 2 raised to the x equal to log base 2 of 9. Repeat the same step. Let f of x equal 1 over x squared, and graph the following individually using primary functions on the xy scale of x from negative 3 to 3 and y from negative 10 to 10. For the first one, we graph the equation f of x. The graph is as follows. For the second one, we do the equation of f of x plus 1, meaning the graph moves up 1. So take the original function from problem A and move it up 1. For C, we do the function f of x minus 2, which means the graph moves to the right 2. So take the original function from A and move it to the right 2. For D, the equation given is cosine of 1 over the square root of f of x plus pi over 2. You can simplify the equation when you plug in f of x and then solve to find the graph. Before we begin this problem, I would like to introduce an abbreviation that I use throughout this problem, which is 3 dots, which equals therefore. For this problem, no justifications are necessary. Let g of x equal the following. First, solve for j of 3 and j of 4. Correction, I said g of x before. It is j of x. For j of 3, plug 3 in for x, and at x equals 3, j of x equals 8. For j of 4, plug 4 in for x, and at x equals 4, j of x equals 10 sine x minus 4. Plug in 4 and solve. For b, you're asked to solve the limit as x approaches 2 from the negative direction of j of x. The equation used is x squared minus 4 over x minus 2. Factor, simplify, plug in, and solve. For C, we're asked to find the limit of x approaches 2 of j of x. Limit of j of x approaches 2 from the negative direction is 4, as we found in problem B. To find it from the positive direction, we use the equation x squared minus x plus 2, plug in, and solve. The limit from both directions equals 4. Therefore, the limit as x approaches 2 of j of x equals 4. D asks, true or false, the function j of x is continuous at x equals 2. Before we found that the limit as x approaches 2 from either side equals 4. Then we have to find what j of x equals at 2, and that is 3. So the statement is false because a j of x approaches 4 from either side, x approaches 2. However, at x equals 2, j of x equals 3. Problem E asks us to find the limit as x approaches 3 from the positive direction of j of x. The equation used is 2x plus 2. Plug in and solve. The answer is 8. For F, we're asked the statement, true or false, the function j of x is left continuous at x equals 4. The limit as x approaches 4 from the negative direction j of x, for that equation, we use 2x plus 2, plug in and solve, and get 10. The limit of j of x as x approaches 4 from the positive direction, we use the equation 10 sine x minus 4. Plug in and solve and get 0. J of 4 equals 0, which we found in problem A. The statement is found as false because j of x approaches different numbers as x approaches 4. G asks, as the limit of x approaches 4, j of x equals what? We found before that the limit as x approaches 4 from the negative direction is 10, and as x approaches 4 from the positive direction is 0. 10 does not equal 0, therefore the limit as x approaches 4 does not exist. H asks, the function j of x is continuous at what numbers? First, we have to look at the options of what numbers it can be discontinuous at. The options are x equals 2, 3, or 4. For x equals 2, we found this in problem C. We found that the limit of x approaches 2 of j of x is 4. But at j of 2, it's 3, and 4 does not equal 3, therefore it is discontinuous. At x equals 3, as you approach 3 from the negative direction, the limit equals 8. As you approach 3 from the positive direction, the limit equals 8. Therefore, the limit as x approaches 3 of j of x equals 8. When you plug in 3 for x, j of 3 equals 8. Because the limit and j of 3 both equal 8, j of x is continuous at x equals 3. For x equals 0, we found in problem G that the limit as x approaches 4 of j of x does not exist. Therefore, it is discontinuous. So we found that j of x is discontinuous at x equals 2 and 4. Evaluate the limit. First, take the limit and factor it out so you can eliminate a variable from the top and from the bottom. Then, plug in what t approaches into the equation and solve. Evaluate the limit. First, find a common denominator and combine the equations. Then, simplify. Finally, plug in 0 for t and solve. If the following limit equals 1, then find the value of limit of g of x as x approaches 5. First solve for g of x in the equation given. G of x equals x plus 6. Now find the limit of g of x as x approaches 5. Plug in the equation you found, then plug in 5 and solve. Find the equation of the tangent line of f of x given at x equals 2. First, find the point by plugging in 2 for f of x. The point is 2, 12. Now, use the limit equation, limit as h approaches 0, of f of a plus h minus f of a over h, and plug in f of x from above. Simplify, and you get limit as h approaches 0 of 3a squared plus 3ah plus h squared plus 2. Then plug in 0, and you get the slope is 3a squared plus 2. Now, at x equals 2, plug in for 2, and you get 14 as your slope. Now take what you know, your point from above, and your slope of 14, and plug into the formula y minus y1 equals m x minus x1. Your solution is y equals 14x minus 16 when you simplify. Let f of x equal the following. Find the value of a and b so that f of x is continuous. First, find the limit as x approaches 2 from the negative direction. The steps are as follows. The answer is 2. Then find the limit as x approaches 2 from the positive direction. Instead of having just a single number as an answer, you have an equation, 4a minus 2b plus 3. Then find the limit as x approaches 3 from the negative direction. Again, you have an equation as an answer, 9a minus 3b plus 3. Finally, find the limit as x approaches 3 from the positive direction, and you get the equation 6 minus a plus b. Then, set the limit as x approaches 2 from the negative direction equal to the limit as x approaches 2 from the positive direction of f of x. The answer is as follows. Then do the following with x approaches 3 from the negative and positive direction. Set them equal to each other, and their answer is as follows. Next, we're going to take the equation that we found when we set the limit of x of 2 equal to each other, which was 1 equals 4a minus 2b, and we're going to multiply it by 2 each side to get 8a minus 4b equals 2. Next, we're going to take these two equations, this one and this one, and set them on top of each other and subtract down to get 2a equals 1. Then solve for a, and a equals 1/2. Next, we're going to solve for b. I'm going to use the equation from above because it has the smallest variables and it's easy to solve for b. The steps are as follows, and b equals 1/2. So, therefore, f of x is continuous at a equals 1/2 and b equals 1/2.